So for our examples, we're going to use the definition of continuity to determine if we're continuous at x is equal to 1. So first step, you have to look at f of 1. What is the value of the x value at 1? What's the y value of the graph? You can see the point is at 3. Second step is to look at the limit as x approaches 1 from the left of the function. As we approach the graph from the left of x is equal to 1, we're at the y value of 2. Also look at the limit as x approaches 1 from the right of the function. So come from the right side of x is equal to 1. You can see the graph is also going towards 2. So since the limit from the left and limit from the right are equal to each other, the limit as x approaches 1 of f of x is also equal to 2. Then the third step is to check to see if the limit as x approaches 1 of f of x is that equal to f of 1. Since the limit as x approaches f of x is equal to 2 and f of 1 is equal to 3, they're not equal to each other. Therefore, f of x is discontinuous at x equals 1. Second example, we're going to look at f of x is continuous at 2. F of 2 is equal to 4. See the y value of f of 2 is at 4. Looking at the limit as x approaches 2 from the left of f of x. So approaching that x value of 2 coming from the left side. The graph is going towards 4. Looking at the limit as x approaches 2 from the right side of f of x. Along the graph coming from the right side of x is equal to 2. The graph is going towards 4. They're equal to each other, so the limit as x approaches 2 of f of x is equal to 4. So we've completed the first and second step. In the third step, is the limit as x approaches 2 of f of x equal to f of 2? Since the limit as x approaches 2 of f of x is equal to 4, and f of 2 is also equal to 4, they are equal to each other. Therefore, f of x is continuous at x equals 2. Our third example, we're going to see if f is continuous at x equals 3. So f of 3 is equal to 1. There's where the y value of 3 is. Looking at the limit as x approaches 3 from the left of f of x, coming from the left side of our function. The graph is going towards 1. Looking at the limit as x approaches 3 from the right side of f of x. So as we approach 3 from the right side, our function is going towards that y value of 2. Those two are not equal to each other, so the limit as x approaches 3 of f of x does not exist. Therefore, f is discontinuous at x equals 3 since the limit as x approaches 3 of f of x did not exist. In our fourth problem, we're going to look at, is g continuous at x equals 1? Take a look at g of 1. The value is 2. Looking at the limit as x approaches 1 from the left side of g of x. On our graph as x goes to 1 from the left side, the function is at 2. Then the limit as x approaches 1 from the right side of g of x. So again, approaching 1 from the right side, g is also equal to 2. Since those two are equal to each other, the limit as x approaches 1 of g of x is equal to 2. And now we'll check in step 3 to see if our limit and our y value were equal. The limit as x approaches 1 of g of x was equal to 2, which is equal to our g of 1, which was also 2. Therefore, g is continuous at x equals 1.